Dear student, good afternoon and welcome you to my YouTube channel Learning Island. Now I am going to discuss the numerical solution for chapter number 8 from physics of class 10. So before this I had already uploaded 7 videos. So this is the 8 number videos. So please watch my previous 7 videos where you can get the solution for numericals of chapter 8a. Now I am going to teach you the from question number 25 to 31 chapter 8b. So let us start without any delay. So first of all I will proceed with the same system as I suggested you, that you go to step by step for any kind of numerical solutions. So it will be easy, because if you think at a time with all these steps, it will be very difficult for you. So it is better to go step by step. So let us start. So it is written that a particular resistance wire has a resistance of 3 ohm per meter. So if the wire length is 1 meter, then resistance is 3 ohm. So it has been said in the part A that 3 wires of length 1.5 meter long, so connected in parallel. So let us draw 3 wire of 1.5 meter length. So the resistance would be 3 into 1.5, because the resistance of 1 meter length is 3 ohm. So the resistance of 1.5 meter length would be 3 into 1.5, that is 4.5 ohm. Now it has been said that these 3 resistors are connected in parallel. So the circuit will look like this. Now in portion A, we have been asked to find out the total resistance of this circuit. As these 3 resistors are connected in parallel, so the equivalent resistance of the circuit, if it is capital R, so we can write 1 by R equal to 1 by 4.5 plus 1 upon 4.5 plus 1 upon 4.5. So on simplification we are getting 3 upon 4.5, that is 1 upon 1.5. So the resistance would be 1 upon, that is 1.5 ohm. So question A, the answer would be resistance equal to 1.5 ohm. Now come to the point B. The potential difference of the battery which gives a current to the 2 ampere in each of the resistance. So here current is I equal to 2 ampere in each of the resistance. So let the voltage applied here is V. You have to find out this what. So by applying the Ohm's law, V equal to IR, if the point A and it is the point B, the applied voltage here. So in point A and point B, the potential difference will be B. So if the current is flowing I, then the voltage would be V into I. So here we know I is 2, and R is 4.5. So the final is coming 9 volt. So B is equal to 9 volt. Now come to the question number C. The resistance of 5 ohm length wire of the same material. So if the length is 5 meter, then the resistance would be 5 into 3 ohm, that is 15 ohm. But it has also been said that the wire is the length is 5 meter, but cross section area is doubled. So as we know that resistance varies inversely with the cross sectional area. So if the cross sectional area increase, the resistance will decrease, and if the cross sectional area decrease, resistance increase. So here the final resistance R dash of the 5 meter length would be 15 by 2, that is 7.5 ohm. So this is the answer. So please get the final answer here. So you can pause the video and write it down. So I am uploading video such that the first page I am showing you the fundamentals, how to solve the problem, and in the second slide I am showing you the final solution so that you can get it very easily. Now let us come to the question number 26. What is given here? The same fundamental, go step by step. So a cell supplies a current of 1.2 ampere through 2 ohm resistor connected in parallel. A cell supplies a current of 1.2 ampere through 2 ohms resistance connected in parallel. So first of all, write down the circuit. The 2 ohm resistance are connected in parallel. So the circuit will be like this. So 2 ohm, and if the we have to find out the internal resistance and e.m.f. So let the e.m.f here is epsilon and internal resistance of the battery is R. Suppose this is the internal resistance, this is our cell. So now current flowing in this circuit is 1.2 ampere, that is I. Is I1. Now in the second case, when resistors are connected in series, if the same resistors are connected in series and connected with the same battery with epsilon 0 e.m.f and smaller internal resistance, then current flowing through this circuit I2 is equal to 0.4 ampere. These are 2 ohm, 2 ohm, 2 ohm, 2 ohm. Now question number Roman 1, that we have to find out the internal resistance and the e.m.f. So we had already let the e.m.f is epsilon and the internal resistance is R. So from figure 1 we get, to find out the current we have to find out the total equivalent resistance here. So if the total equivalent resistance of these two resistors is R dash or R1, then we can get 1 by R1 equal to 1 by 2 plus 1 by 2. This is for this. So it is coming what? It is coming 1. And R1 is equal to 1. But the total resistance of the circuit will be, here you see these two resistors are connected in series with the battery. So this is also smaller. So the total resistance of the circuit will be smaller plus 1 ohm. So current I1, so you can write epsilon E equal to I1 into R plus 1, because B equal to IR. Now here I1 is 1.2 ampere, so smaller plus 1. So this is equation number 1. Now in this case also we can find out the total equivalent resistance. If it is R2, then we can get 2 plus 2 plus smaller, it is 4 plus smaller. So in the same way, applying the Ohm's law, we can find out E equal to I2 into 4 plus R. So this is I2 is given 0.4 ampere, so 4 plus R. This is the equation number 2. So comparing these two equations, we can write down 1.2 R plus 1 equal to 0.4 4 plus R. So on simplification we can get 1.2 R minus 0.4 R equal to 1.6 minus 1.2. So finally we are getting 0.8 R equal to 0.4 4. So on further simplification, we are getting R equal to 4 by 8, that is 0.5 ohm. So the answer for the question number 1, that is internal resistance equal to 0.5 ohm. So putting this value of R in equation number 1, we get E equal to 1.2.5 plus 1. So that is 1.2 into 1.5. So we are getting finally what? 5 12s are 60. So 0. 12 ones are 12. So it is 1.8. So 1.8 volt. So the answer for the question number 2 is here e.m.f equal to 1.8 volt. So hope you understand this. Now let's find the final solutions here. You pause my video and write it down. Let us go to the next question. Question number 27. What is said here? It has been mentioned that a battery of 15 volt and an internal resistance of 3 ohm is connected to two resistors of 3 ohm and 6 ohm connected in parallel. So what happened? First draw the circuit. So if this is 3 ohm resistance and another is 6 ohm resistance, which are connected in parallel. Now this connection is connected with a battery which EMF is 15 volt and internal resistance is equal to 3 ohm. So in A, it has been asked that the current through the battery. What is the current flowing through the battery? So let the current flowing through the battery is I. So to find the current, we will have to find out the total equivalent resistance of the circuit. Here, see, these two resistances are connected in parallel. So let the equivalent resistance of the circuit of these two resistors is R1. So we can apply 1 by R1 equal to 1 by 3 plus 1 by 6. So that is coming 2 plus 1. That is 3 upon 6. Finally 1 by 2. So R1 is coming 2. And here also you see these two resistors again connected with the in series with the internal resistance of the battery. So the final resistance of this circuit is 2 plus 3 equal to 5 ohm. So the current would be applying the Ohm's law V equal to I into R. So we can write I equal to V by R. Here V is the EMF. It is 15 by 5. That is 3 ampere. So current flowing through the battery. The answer for the question number A is 3 ampere. Now question number B. Potential difference between the terminals of the battery. The potential difference between the terminals of the battery, if this is that is V. So if it is V, we can write V equal to E minus total EMF minus the loss of voltage because of internal resistance. So that is I into R. To find out the potential difference between the terminal of the battery, we apply this formula. V equal to E minus I into R. So E is 15 volt, I equal to 3 ampere and R is 3. So here it is coming 15 minus 9 equal to 6 volt. So the answer is 6 volt. Now question number C. The current in the 3 ohm resistors. So current in the 3 ohm resistors here, that it is I1. As in this point A and B, the voltage across this point is equal to the voltage across the terminal of the battery. So here potential difference between A and B is 6 volt, and current in the resistance, if it is I1, so I can write I1 equal to V by R, that is V equal to 6 volt, R is 3 ohm, so the current is 2 ohm. So the answer for the current is 2 ampere, so it is ampere, so current is 2 ampere. So it is clear. Now D, the current in 6 ohm resistors. So for 6 ohm resistors you can find out in the same way. If the current in the 6 ohm resistors is I2, so you can apply here I2 equal to V by 6, that is V equal to 6 by 6 equal to 1 ampere. So all the answers has been done. So let's go to the final solution for this. This is the final solution, page 1. This is the final solution, page 2. So please write it down. Let us go to the next question, question number 28. So here you see, again step by step we will go. The circuit diagram in the figure shows 3 resistors 2 ohm, 4 ohm and R ohm connected to a battery of e.m.f 2 volt and the internal resistance 3 ohm. Here you see the e.m.f of the battery is, it is E epsilon, and it is the R internal resistance. Now we'll have to and the current is 0.25 ampere in the circuit. Now in A, the PD across the 4 ohm resistors, potential difference across this. So if it is A and B point, so we have to find out. Here you see, as the current is 0.25 ampere flowing through this, so the potential difference would be here I into R, that is 4 ohm. So I is 0.25 into 4 will be equal to 1 volt. So here the voltage drop is 1 volt. So the question number A, the answer is 1 volt. Now B, in B, the PD across the internal resistance of the cell, PD across the potential difference across the internal resistance. So to find it out, we'll apply the law like this. Here you know the resistance is smaller, so potential difference again across the battery in internal resistance is I into R, that is current is again 0.25 into R is 3 ohm, so it is 0.75 volt. So in case of question B, the voltage difference across the internal resistance R equal to 0.75 volt. Now question number C, the PD across the R ohm or 2 ohm resistance. Now we have to find out the PD potential difference here. So how will it find out? How will you find it out? Here you see the total voltage here would be, this is the 2 ohm was the main voltage, and so the across the battery terminal the voltage would be, if it is here you see I am getting directly, if I redraw the cycle, if I redraw it the circuit like this, it will be very simplify, it will be very easier for you to understand. This is the battery, there is an internal resistance of this battery R, it has not been shown in the circuit properly, so I am drawing it again. So here you see the voltage drop is happening here and here. So if the total EMF is 2 volt, so if I deduct this 2 voltage drop from the main voltage 2 volt, we will get the voltage drop here. in this, if it is x and y point, if it is x and y. So the total voltage drop here in the internal resistance, the total voltage was e.m.f, that is 2 volt. Some drops here in the internal resistance of the battery, some drops in the 4 ohm resistance. So finally it is getting the voltage here. So the voltage between the point endpoint of 2 ohm resistance or R ohm resistance would be equal to 2 minus 0.75 plus 1, that is coming 1 minus 0.75, that is 5 to 0.25 voltage. Now question number D. What is the value of R? Value of R is the, the current is this, so that here I can find out the total equivalent resistance of the circuit would be, here you see current is 0.25 ampere and the E was, that is the 2 volt, so R would be 2 by 0.25, it is coming 200 by 25, so 8 ohm. So R is coming 8 ohm. This is not R, the total equivalent resistance of the circuit is 8 ohm. So as total is 8 ohm, so the total equivalent of this circuit, 2 ohm and R ohm, between this 2 ohm and R ohm, the equivalent resistance would be this 8 minus 4 plus 3, that is 1 ohm. So if it is 1 ohm, so we can, if the equivalent resistance here is 1 ohm of these two resistors, so we can write like this, 1 by 1 equal to 1 by 2 plus 1 by R. So I am getting 1 by R equal to 1 by 2, that is R equal to 2. So the value of R is coming 2 ohm. So hope this is clear to you. If you find difficult to understand, please run this video, it's in slow motions, or you can pause and try it yourself first, then watch my video, then it will be very much beneficial for you. So let us find the final solution for this. This is the final solution for this, is the second page. So please write it down after pausing the video. Now go to the question number 29. So here again we will follow the step-by-step process. That is what is given. The given data is here, the three resistors of 6 ohm, 2 ohm and 4 ohm are joined in an emitter. Joined an emitter A and cell of e.m.f 6 volt as shown in the figure. Calculate the effective resistance of the circuit. Here you see, emitter has no resistance. This is the total voltage applied here. This is the R1 resistance. So R1 is, here these two resistance are connected in a series. So the equivalent resistance for these two resistance would be 4 plus 2, that is 6 ohm to 6 ohm, and again these two are connected in parallel with this. So if the total equivalent resistance is R of the circuit, then I can write 1 by R equal to 1 by 6 plus 1 by 6. This is coming on simplification 1 by 3, so R is coming 3 ohm. So the effective resistance, first questions for A is coming it is coming 3 ohm. Now question number B, the reading of the emitter. So emitter of the reading is actually the current flow. So we know that the current flow is I. So as per Ohm law we can apply V equal to IR. It is very easy. So I would be equal to V by R. Here R is 6 volt, or voltage is 6, R is 3, so the current is 2 ampere. 2 ampere. So the answer for the question number B is 2 ampere. So this was the very easy. Now let us go to the final solutions. This is the final solutions. Now let us go to the question number 30. In 30 there is a diagram. So in this diagram you see there is two parallel circuit which are again connected in series. So we'll have to find out the total resistance of the circuit. So to find out the total resistance circuit, we have to always consider the point of the battery from where the current is. So this is the 2 point X and Y. We have to find out the voltage against this point. So if I start coming from here, we see that these two resistors are connected in series. So if the equivalent resistance of this is R1 and the equivalent resistance of these three are R2, so 1 by R1 would be equal to what? Would be equal to 1 by 10 plus 1 by 40. So on simplification we are getting 4 plus 1, it is 5 by 40, it is 1 by 8. So R1 is coming 8, and for this 1 by R2 will be equal to 1 by 30 plus 1 by 20 plus 1 by 60. So this would be, on simplification, we are getting 2 plus 3 plus 1, so it is 6 by 60 equal to 1 by 10. So this R2 is coming 10 ohm. So hope up to this it is clear. Now these two resistance again connected, R1 and R2 connected in series. So the total resistance of the circuit would be R1 plus R2, that is 8 plus 10, so 18 ohm. The question number 1, A, the answer is 18 ohm. Now the reading of the emitter A. So to find out the emitter reading, we have to find out the current. So again apply for B, let current is I. So applying Ohm's law, B equal to IR. Here B is 1.8 volt. So I would be equal to 1.8 by 18. So if I cancel it out, it is coming 0.1 ampere. So current flowing through the circuit is 1 ampere. So it is also clear to you, I think. So this is the final solutions. This is the circuit diagram of this circuit diagram, and this is the solutions. So please note it down after pausing the video. Now go to the next question, 31. This is the last questions. It is also very easy. A cell of e.m.f 2 volt. Here the cell has e.m.f. So if I start step by step, here epsilon equal to 2 volt, and internal resistance R is 1.2 ohm. So if I draw the circuit again, this is coming battery. Here this is internal resistance R, this is E. So here it is ampere, emitter, here it has resistance 0.8 ohm. Now this is connected to the parallel circuit of this. So this is like this. Now so we have to find out the reading of the emitter. So to find out the reading of the emitter, we need to find out the total equivalent resistance of circuit. So these are in parallel. So if the equivalent is R1 here, so we can find it out like this: 1 by R1 equal to 1 by 4.5 plus 1 by 9. On simplification it is coming 2 plus 1, it is 3 by 9 equal to 1 upon 3. So R1 is coming, 3 ohm. So the total equivalent of this is R1 equal to 3 ohm, and here it is 0.8 ohm. Now it is 1.8 2 ohm. So the total equivalent resistance of the circuit is R equal to R1 plus 1.2 plus 0.8. It is coming 3 plus 1.2 plus 0.8. So on adding this, it is coming 3 plus 2 equal to 5 ohm. So finally the answer of the question number A is 5 ohm. No, not 5 ohm. This is the resistance. So the current flow is I equal to e.m.f is 2 volt by 5. So that is coming 0.4 ampere. So answer is 0.4 ampere. So current flowing through the circuit, that is the reading of the emitter is 0.4 ampere. Because voltage is 2 volt and the resistance of the circuit is coming 5 ohm. So the current flow is 0.4 ampere. Now the second part, the potential difference across the terminal of the cell. Across the terminal of the cell, here again we will apply the same formula, that is the terminal voltage, same formula, V equal to epsilon e.m.f minus loss in the internal resistance. Which loss? The potential difference, that is the voltage loss. So E is given 2, so I have already find out 0.4 and the resistance is 1.2. So it will come to, that is 0.48. On subtraction we are getting 2, 5, 1.5 volt. So the answer of the question B is 1.52 volt. Now the potential difference across the 4.5 ohm resistors. So this is 4.5 ohm resistors. We'll have to find out the potential difference across this. Now here you see the potential difference across these means potential difference across this point. So if I consider the total voltage e.m.f was 2, so loss happens in the internal resistance, it is 0.48. now so you can do it directly because the potential difference across the battery was 1.52 volt. So here is a loss in ampere in emitter. So if I deduct the loss in the emitter, we will get the voltage here across this point, means across this resistance. So let us do it. So if I deduct from it is I am doing division here. If 1.52 voltage was between two terminal of the battery, so if I deduct 0.8 into 0.4, that is the voltage drop against the emitter, because current is 0.4 and resistance is 0.8. so 0.4 into 0.8, we are getting 1.52 minus 0.32. so it is coming 0 to 1.2. so 1.2 voltage are there across this 4.5 ohm resistance. So this is clear to you. Let us find the final solutions here. This is the first page of the solutions and this is the second page of the solutions. So this is the final result. So hope you find this video very beneficial for you. If you really find this beneficial, please subscribe my channel and also forward the video to your friends so that they can also get the benefit out of it. Thank you. I will see you again in the next video. Thank you. Bye bye.